Morning, everyone. This is Dr. Chris Myers here with the Second Nasos, and welcome to the first lecture in the Nutritional Series that I'll be performing for you over the next several months. The idea is to do 1 to 2 lectures a month, giving you some basic concepts on nutrition to help you make better decisions with your training and what you eat. Before we can get into all the nutritional stuff, we need to discuss why we eat and how it affects energy production in the human body. And that's going to be the focus of this first lecture. We're going to discuss the basics of metabolism and the energy systems. So within this lecture, we're going to have 4 different objectives. The first is to understand the basic metabolic definitions, describe the different energy pathways and how we convert the food that we eat into the energy that the body utilizes, and how the body differentiates between the energy pathways between intensity and duration for exercise. And finally, what fuel sources are utilized through these different energy pathways. So with this first one, let's define metabolism. Metabolism is, simply put, is the total of all energy transformations that occur in the human body. So basically what this means is when you put food in your mouth, you chew it, you digest it, it's converted into energy that the body utilizes for all the biological processes to get you through the day. And so we drill that down into what we call bioenergetics. And this is the subcomponent of metabolism, basically where you convert food that you eat, into the macronutrients of carbs, fats, and proteins into a molecule called adenosine triphosphate, also known as ATP. So ATP is the end state of what all food is converted to. And this is the energy molecule that the body utilizes to do any of its biological processes. So for example, every time that you move your arm, let's say you're doing a bicep curl, when that muscle contracts, it utilizes adenosine triphosphate or ATP to be able to do that muscular contraction. Also, every time the heart beats, it's utilizing ATP. Every time that you want to speak, you think, you're utilizing ATP. It is the basic energy source for everything in the human body. And so I'm bringing up the first law of thermodynamics when we discuss bioenergetics and also metabolism, because what the first law of thermo says is basically energy is neither created nor destroyed. It's just transformed. And that's really what we do when we eat food and digest it. When you put food in your mouth, you chew it, you start breaking it down, you swallow it. And when it enters the GI system through the stomach, it's broken down through chemical processes. And when it's broken down into its subcomponents of carbs, fats, and proteins, those elements are then changed into adenosine triphosphate through several different energy systems. And that provides the energy for the body. And that's really what we're saying with all of this. So when we talk about bioenergetics and the creation of adenosine triphosphate, the body does it through 3 different processes. The first 2 of the processes are called anaerobic, and these are what we call the phosphagen pathway, which is the first one you see here. And then the second is what we call anaerobic respiration or glycolysis. And what we mean by anaerobic processes is the body does not utilize oxygen to create the adenosine triphosphate. And then the third process where we create ATP is what we call aerobic respiration or oxidative phosphorylation. And basically what this means is you utilize oxygen to create the adenosine triphosphate through the fuels that you ingest. Now, these 3 pathways are important because this is how the body creates the energy necessary from the fuels that we input. And it's all based on intensity versus duration. And so when I talk about intensity versus duration with exercise, we're talking about how hard you go versus how long you go. So let's think about it. When you're doing a 100-meter sprint, you're going as hard as you can go for 100 meters. You can only hold that intensity for a few short seconds, depending on how how well you're trained, you can only hold it from anywhere from 8 to 12 seconds. And then let's say you're doing a 400-meter run. You drop in the intensity a little bit, but you can run longer. You can run longer, up towards to 2 minutes based on your training ability to hold that effort. It's the same thing in the weight room. If you're doing a 1 rep max, the maximum amount of load that you can push, let's say on the bench, you can only do that once, maybe twice. But let's say you drop that load down, 5 to 7%. So you're, say, 92% of your 1 rep max. You're able to do 2 to 3 lifts. You drop it down to, let's say, 80% of your 1 rep max. You're able to do 10 reps. Well, by looking at these different variations of intensity versus duration, it determines, which energy system that you're utilizing. And so let's further break it down. So when we talk about doing an effort between 0 seconds to 2 seconds, the body is utilizing the stored energy that it has in the muscle. So it's not creating anything new. So let's say you move your arm to pick up a pen. The body is not creating new energy to be able to do that. But let's say you're moving into the gym now and you're getting ready to do a three repetition strength set. So you're trying to build some power. And so if you look at the duration of that 3 reps, it's probably about 3 to 5 seconds in length, which is roughly at about 92% of your intensity, the maximum 92% of the 1 rep max that you're able to push. And so within this time zone, the body is going to utilize phosphocreatine pathway to create its energy, because it's such a quick energy pathway to create the ATP necessary to do that movement. Let's say you're going to drop the intensity. You want to do a hypertrophy set where you're doing 8 to 12 reps of anywhere between 78 and 87% of your 1 rep max. When you do a set like that, and if you're doing it properly, with a 1 second down, 1 second up type movement, it's going to last anywhere between 8 to 15 seconds. And so when you're talking about that type of pathway, you're moving a little bit out of that phosphagen pathway into what we call glycolysis. And this is where the body is changing its energy pathway to create ATP through different energy sources. And so let's talk about, you're doing an endurance event. Let's say you're going out and running 5K for time. And if you're, depending on how well trained you are, 5K is going to last anywhere between 18 minutes and 30 minutes. Well, that intensity is much lower if we follow this black dotted line here, right? And so we're talking about an effort somewhere in this length of duration between 15 and 30 seconds. And that's going to be anywhere between 50 and 70% of your max effort. Well, the body is not going to be utilizing the phosphagen or the glycolytic pathway as its main energy source. You're going to be utilizing oxygen to help create that ATP. And that's what we call that aerobic pathway. And let's put this into a different scheme. So let's look at, let's overlay the different systems. And so if we're looking at near maximum efforts between 0 and 30 seconds, the primary pathway for creating adenosine triphosphate is through this phosphagen system, also known as, you'll see it written as PCR system. Efforts between 20 and 30 seconds, all the way up to 2 minutes, comes from anaerobic glycolysis. And this, again, we're saying we're not utilizing oxygen to create the ATP. And then finally, when we're looking at efforts roughly at about the 2-minute mark, all the way up to 24 hours in the day, we're talking about the oxidative phosphorylation system, or the aerobic pathway to create this energy. And so this is where this concept of intensity duration versus duration becomes highly important, because if you're going as hard as you can only go for short periods of time. So that's going to help determine if you're going to be utilizing the PCR pathway or the phosphagen pathway versus the anaerobic pathway. And also, if you're going much lower, you can go in intensity, you can go much longer. And so depending on how hard you're going versus, how hard you're going versus how long you're going, that's going to determine if you're going between anaerobic or oxidative. It's important to understand this because this is one of the baseline concepts that we're utilizing to train. And so, for example, I'm having everyone perform a 5K, 5 kilometer rowing time trial to get a particular heart rate. And I call that a threshold test. And by doing this type of test, we can gather what's called your threshold heart rate. And with this threshold heart rate metric, we're able to calculate different training zones based on your heart rate. And within those, and with the correlation of those training zones, it helps determine which metabolic pathway I want you to train in. And I'll break this down a little bit further in the next lecture coming up in a few weeks. But this is the basic concept with it. Also, by discussing this, we can also start discussing nutritional strategies and so forth. And one of the big ones here is when we start talking about the phosphagen pathway, also listed here is the ATP PCR system, is how can we better affect this? Because with a lot of the work that you do in the gym, a lot of the strength training and such, you're going to be covering both the PCR system and the glycolytic system. And so one of the first things that comes up with this this type of work and discussion is creatine supplementation. And does it really work? And so when we talk about the creatine supplementation, we are talking about supplementing the phosphagen system pathway. And so the way this pathway works is the body takes the molecule of phosphocreatine, breaks that apart, releasing the phosphagen atom, and combines it with the molecule of adenosine diphosphate to create adenosine triphosphate. Okay, that's how this system works. And also to release the energy, it just reverses it. The body just breaks that adenosine triphosphate into adenosine diphosphate and the inorganic phosphate molecule. So when we do creatine supplementation, you're affecting the phosphagen pathway. And again, that phosphagen pathway really primarily works at very high intensities, near max, with a duration anywhere between 8 and 12 seconds of work. And so what happens is when you ingest creatine, just in a drink or in a sports mix, you're providing more of that creatine molecule to be able to bond with more phosphate molecules to create PCR in the body. And the thought process is if you're able to increase those PCR stores ever so slightly, you're able to do a little more work in that phosphagen creatine pathway. And so translating that into the gym, you can do a couple more reps at high intensity, and you can also recover a little bit faster. That allows you to do maybe 1 or 2 more sets. And so if you're able to do a few more reps with an increased recovery and a couple more sets, you gain strength, speed, and size a little bit faster. That is the thought process. And so with the supplementation, you're trying to negate that immediate depletion of the phosphocreatine through the phosphagen pathway. Now, there are a couple of different types of creatine supplements out there. Research is showing that creatine monohydrate is the best to utilize to better to affect this pathway. It's shown to have to actually increase the phosphocreatine stores in skeletal muscle, and also it is definitely shown to improve high intensity performance within that path during that duration that I'm always talking about with phosphocreatine, within the phosphagen pathway. Again, that 8 to 12 second time frame. And also, it inherently helps increase strength and fat-free mass, basically building muscle. Because again, if you're increasing the amount of energy stored, you're able to do a few more reps, you're able to recover a little bit faster. And so by increasing that workload, being able to do a little more work, you're able to increase your recovery a little bit more. You're able to have those gains a little bit faster. And that's what this is doing. And there's been some talk out there in recent years that creatine can help, that hurts the kidneys and also some cardiovascular risks. Research is showing that that's not really the case. As long as you don't abuse it, you follow the directions, do it properly, you're fine. But the one thing you do need to do with this is you do want to ensure that you push water, because it will dehydrate you a little bit more. So if you are doing creatine supplementation, ensure that you are increasing your water intake. And finally, with any other supplements, and we'll discuss this probably in lecture 3, is the variability of the purity that exists, because federal law does not really have a lot of oversight when we talk about nutritional products, and I'll get into that. So just if you are supplementing with creatine, do your research. That's what you need to do. And finally, when we start talking the last energy pathway, which is the utilization of oxygen to create ATP, is through oxidative phosphorylation. This is the primary pathway that you create energy for aerobic endurance. And so when we start talking about in the next upcoming lectures about carbs, fats, and proteins as the fuel sources, we're going to primarily be talking about how carbs and fats are utilized for ATP production through the aerobic pathway. Because when you're running or ruck marching, rowing, anything over long distances, again, for durations greater than 2 minutes, these are your primary fuel sources. And we'll talk about how intensity and duration affects this. But just remember, with this pathway, you have to have oxygen to create ATP. If you don't, you're not going to create it. So over this lecture, we covered some very complex concepts of metabolism and the energy pathways. But I just want to introduce these to you so you can kind of have a basic understanding on how these apply to fuel sources when we start getting into that portion of the lecture series. So to summarize what we've talked about, we discussed what is metabolism. We defined metabolism. We also defined bioenergetics and what the basic form of energy in the body is, and that is adenosine triphosphate. We briefly discussed the 3 types of energy systems. Again, the first one is the phosphagen system. The second is the glycolytic system. And remember that the phosphagen and the glycolytic systems are considered anaerobic processes. And these are processes that do not utilize oxygen to create adenosine triphosphate. And that third process, which is called oxidative phosphorylation, also known as aerobic respiration, utilizes oxygen to create ATP. And then finally, we discussed how intensity versus duration and exercise helps the body to determine which energy pathway it utilizes to create adenosine triphosphate to do the work that you want to do. Thank you very much for your time. If you have any questions based on this or like further information, please feel free to contact me. This is my email, and I'll see you in the next series, in the next lecture. Take care.